This is 2.6 transformations part 1. We're going to be doing lots of parent functions and transformations in this unit and the next. But first, let's start with a little warm-up. Can we tell if this function is going to be even, odd, or neither? Remember, we have to determine it algebraically. So the algebraic test, we have to put a negative x in for all of the x's that exist. So we put a negative x squared minus 6. Anytime you square a negative, we would get a positive. So 2x squared minus 6. I want to compare that to our original, and they happen to be the same. So that tells us that this is an even function, and even functions mean that they are symmetric to the y-axis. All right, so before we get into transformations themselves, we're going to be looking at each of the parent functions. These parent functions are really important. You need to be able to look at them and know exactly what they look like. So be sure to study each of these parent functions and know the general points that are on each one. So y equals x squared. If we make a quick table of values here, this hopefully you can recognize by now as a parabola that has a vertex at 0, 0. So we want to find a couple points on either side of that vertex. If we put 1 into x squared, you get 1. 2 into x squared, you get 4. Negative 1 is 1. Negative 2 is 4. Then we're going to graph it. So 0, 0, 1, 1, 2, 1, 2, 3, 4. And you'll definitely want to have these sketched on your paper as well, even if you don't have graph paper. And then connect the points. Sometimes I see people plot the points and then not connect them. Well, I probably shouldn't have done that sideways. I'm trying to write sideways here, but made my graph kind of look sideways. All right, so that's our first parent function. Here's our next one, y equals the absolute value of x. Again, we're going to make a quick table of values. It also has a vertex at 0, 0, so we're going to go a couple points on the left and the right of that. If you put 1 into the absolute value, it's just 1. 2 is 2. But if you put a negative 1 in, it comes out as a positive 1. Negative 2 is positive 2. So when we graph these, instead of getting a curved line, you should get 2 rays, remember from your geometry day, but 2 straight lines making a V. So the first one we did makes a U, but this one makes a V. All right, so let's talk about transformations. So this transformation, this is our equation for transformations. You'll see the parent function, the x squared, has been added to. So each one of these extra letters does something different. So let's start with the h. This h value right here shifts left or right. Now the tricky part about the h is that it shifts opposite from what it looks like. So this looks like a negative h, but it's actually a positive h. So you have to separate it from that negative sign. So if it said -3, that would actually be a positive 3 and would go to the right. If it said +3, that would actually be a negative 3 and go to the left. All right, k right here shifts or translates up and down. Everybody likes k because k is exactly what it looks like. If it's positive, goes up, negative goes down. All right, and then a has several different things that happen to it. One is it tells us if we're going to have a vertical shrink or stretch. So it's like, does our parabola get skinnier or fatter? And that depends on if the A value is greater than 1 or not. So if the A value is greater than 1, and technically the absolute value of A is greater than 1, it's a stretch. And if it's between 0 and 1, it's a shrink. Now, that's not all that A does. It also tells us if it opens up or down. If your parabola is opening up or opening down. If A is positive, it opens up, and if A is negative, it opens down. Now, what we say for that when we're describing the transformations is we say it reflects over the x-axis. So we don't always say it opens down. We just say it reflects over the x-axis. Okay, so here's what we're going to do. We are going to start by graphing the parent function, that function that we already looked at earlier. Then we're going to state the translations of what happened, and we're going to graph this new function. So when I graph the parent function, I'm going to dot it, but I remember that parent function went through 0, 0, 1, 1, and 2, 4. I also went through negative 1, 1, and negative 2, 4. So here's my parent function, and like I said, I'm just going to kind of dot it so we can see that that's how it was starting. However, we've added this 2. Now this 2 is on the outside of the x squared, so it's in the k position from up here. So that tells us that we are going up 2. So when it says identify the translations, we identified it up 2. So what you're going to do is take all of the points and move them up 2. So this 0, 0, move it up 2. 1, 1, move it up 2. All of the points. And then we connect those. So when you do your assignment, you're going to have to do the transformations on the computer, and then you have to do your graphs on paper, take a picture to submit them. Okay, so 2 different things you'll be submitting for this assignment. Let's try another one. So again, we can identify this as an x squared graph, so we know that our parent function is going to be that one that we practiced, 0, 0, 1, 1, 2, 4, and then negative 1, 1, negative 2, 4. This is how it starts. But then we go to the equation and we see that we have this minus 3. Okay, that's in the h position. And remember, h is the opposite of what it looks like. So even though this looks like minus 3, it's actually a positive 3. So this is going to move to the right 3. So all those points that we just graphed, we're going to move them to the right 3. 1, 2, 3. 1, 2, 3. 3. And then we can connect them with a solid line. So notice our parent function has a dotted line, and then our new one has a solid line. All right, let's try one more before we go on to absolute value. Here we have a 2x squared. So this is the first time we've had an a value. But before we even get there, remember our parent function. We're going to sketch it. And part of having you sketch the parent function every time is so you can see the transformation, but it's also so you can get really used to those points on the parent function. Remember, we talked about how you need to have those parent functions memorized and know what points they all go through. All right, so 2 right here. Remember, the a value has 2 purposes. First, we need to look to see if it's positive or negative. Obviously, this one is positive, so it opens up. That's important for us to know. And then the other thing, we need to see if your a value Is it, that was supposed to be a greater than. Is it greater than 1? Or is it between 0 and 1? So it's got to be one of those two options. So this one was positive, so we know it opens up. This one is obviously greater than 1, which tells us that it's a vertical stretch of whatever that number is. So in this case, it would be of 2. So when you're asked to describe the transformation, we'd say vertical stretch of 2. Now, what does that mean for us on our graph? Well, it means that we would have to multiply the y values by 2. So if I go over to the graph, my 0, 0 doesn't change because 0 times 2 is still 0. But go to 1, 1, and I multiply that times 2, so now it's 1, 2. 2, 4 is now 2, 8. Negative 1 goes to, I'm sorry, it's negative 1, 1, so it still goes up to 2. And negative 2, 4 goes up to 8. So you can tell that this vertical stretch makes our parabola skinnier. That's what stretches do. When you like think about stretching up towards the ceiling, you like stretch real tall, like elongates your body. Same thing here, elongates that parabola. Okay, now we're going to do the same thing, but with absolute value. You'll notice that the absolute value, excuse me, transformation equation has the same letters in it, and they have the same functions. So A is still going to tell us if it opens up or down, or is a vertical stretch or shrink. H is still going to tell us if it moves left or right, and it's the opposite. K is still going to tell us if it moves up or down. So let's try it. Here we want to do the same thing, graph the parent function. So this parent function of absolute value, if you remember, goes through 0, 0, 1, 1, 2, 2, 0, 0, negative 1, 1, negative 2, 2. So we're going to have it dotted on our graph. And then we're going to go and look at the transformations that happened. So plus 2, that tells us that we moved, remember it's the opposite, so this is left 2. But then the negative 3 tells us we're going to move down 3. So we have 2 transformations going on. So every point we're going to move left 2, down 3. So pick a point, left 2, down 3. And you'll see that all of the points move, but it's still the same V shape. They're just all translated left 2, down 3. Okay, we'll do one more of those. This time we don't have any left or right movements, but we have this A value on the outside. Remember, A tells us 2 different things. The fact that it's negative tells us that it opens down. But what we need to say in terms of transformation language, we say it reflects over the x-axis. So that's one piece of what happens. And then remember, you have to take the absolute value. The absolute value of negative 2 is a positive 2, which is greater than 1. So that would give us a vertical stretch. And you always put by how many, so a vertical stretch of 2. Oh goodness, we didn't graph our parent function first, so we got to put that parent function on here. Dot that. All right, so we have 2 things happening here. You can do them one at a time, or you can combine them together. The reflecting over the x-axis is going to take this point and put it down here. 0, 0 is going to stay in the same spot. But the vertical stretch of 2, remember, multiplies the y value. So this 1 becomes a 2. So it's going to reflect over but become a 2. This 2 is going to become a 4. So it's going to reflect over to here, but that it would be a 4 instead. If you want to reflect first and then stretch it, that's fine. Or you can do them both at the same time. So what should happen is it should be opening down, but it also should be quite a bit skinnier since it was a vertical stretch.